So this video is going to go over Beer's law, specifically using what they call the GoDirect Spec Visa Plus, connected directly to your Chromebook. The bonus of using this spectrophotometer is it's going to graph things for you, but it is a little different than the other spectrophotometer. So if you do have your lab, flip it to the data table, because I will be referring to that as I go through the video. And this GoDirect is going to be completely connected directly to your Chromebook. And you're going to have to download Veneer spectral analysis in order for you to use the equipment. So I'm going to minimize here. So for this to work, again, you're going to have a software that you're going to be using. And this is the screen you're going to see. So when you have it connected to your Chromebook, you are going to see that absorbance, transmittance, fluorescence, emission, and advanced full spectrum is given to you. So what you're going to hit is absorbance. And for the first part of this lab, you have to come up with what we call the lambda max, which happens to be what is the wavelength we need to read on. So if we click on that, what it will do is go to this screen, and you are going to see that it warms up the lamp, okay? When this is going on, you are going to place a cuvette that has distilled water in it so that it can essentially do the blanking. So again, make sure that this is distilled water, make sure that the clear end is going through that area, because this is where you have the light path going through. Sorry, I have to go back and forth between these screens. Oh boy. Okay, so place a blank cuvette in the device. That's what it's going to tell you to do. And when you click on it, it's going to say finish calibration, finish calibration. Okay, so this is the screen that you should be able to see. And underneath here, you will see collect button. And we are going to see if we could read all of the wavelengths of the stock solution, So take the blank out and put your stock solution in a cuvette. So this is the highest concentration. This is the 0.15 molarity, and put it into the SpectroVision. Then what you will see on the screen is you're going to hit the collect button. It will then read all of the wavelengths for that sample. So over here on the right-hand side, you're going to see all of the different absorbances, and you're going to try to find the lambda max. Or you could just toggle over to the top of this peak, and the top of the peak will then give you your correct wavelength that you want to read. So if I look over here at the data table, I will see that it's about 0.69 or 0.63 seems to be the maximum that I have for the absorbance. And so that's going to be the wavelength that I use for my experiment. So 512 is going to be what I write down on my lab. Okay, so if I go back to that, so I'm going to write down the lambda max on the lab. So 512 is going to be the nanometers that I'm going to use in this next portion. So I'm going to take my stock out of there, and I'm going to pause this video for a second so I could get my other sample. So for each one of these samples, I'm not going to go back and forth between the screens. I'm just going to show you the screen that starts to graph it for you. But what you're going to see is I'm going to put each one of these cuvettes into the spectrophotometer, and it's going to read the sample's absorbance. So I'm not going to keep going back to the screen because it's the same thing. You're just changing the cuvette. Again, just be mindful of what your side that you're putting in there. So I am going to go to this screen and I'm going to hit stop because now that I have my Lambda Max, I don't need it anymore. So go over to the top here where it says untitled and hit new experiment and hit no, don't save because I don't need that graph. I am now going to go and look at absorbance concentration Beer's law. So if I click on that, that's going to be the experiment that we are going to read our samples. Okay, so this is where I put what I call my Lambda Max. So this is where I'm going to type in 512. Okay, and I'm going to hit done. Okay, so that's the wavelength that it's going to read. So you will see on the top here, it says collect. And over here on the bottom, you will see the absorbance is 0.532 at that particular one. So if I hit collect, what it's doing is essentially going to start to collect the data on the absorbance. Now, I don't see any fluctuation. Usually you see a fluctuation once you put it in there. So if I hit keep, okay, this is where you're going to type in the concentration. So for letter A, my concentration is 0.12. And you're going to say keep point. So it is plotting it on the graph. So again, I'm not going to show you me putting in the next cuvette. This next cuvette is going to be sample B. So the next cuvette is going to be sample B. And you will see here on the bottom right, you will see the absorbance at 0.411. So once I see that it's pretty stable, I'm going to hit the keep button. Okay, this is where I type in my concentration of 0.09. So I'm going to keep that point. And again, it's now plotting those 2 points on my graph. Again, take out the B and put in letter C. Okay, so letter C is going in there. You could tell by the fact that my absorbance went down. Now it's stabilizing. Once I see that that number is pretty consistent, I'm going to hit the keep button. And now my next concentration is 0.045. And I'm going to keep that point. So I put in the wrong concentration for that last sample. So it should have been 0.06. So I'm going to go back and change that once I get through my other samples. So again, I will show you that once I read this sample. So I'm going to read, this is going to be letter D. So I'm going to click on the keep button, and letter D's concentration is the 0.045. So again, I'm going to keep that point, okay? And I'm going to go back to, I believe I could go into data set once I stop. So let's go back to that. I'm going to put in letter E into the spectrophotometer. I could see when the absorbance is pretty consistent. I'm going to hit the keep button, and this is going to be 0.03 and keep point. Okay. So now that I've read my 5 samples, I'm going to hit the stop button. Okay. Then I should be able to go in and change the data set. So I'm going to change this to 0.06 and enter that. That's going to look a lot better because this is going to be, again, a straight line that you should get with Beer's law. So again, if you don't remember, we're going to put a line of best fit through this data. So I'm going to go down here to the bottom where it says graph tools, and I'm going to hit apply curve fit. And it's going to automatically go to linear and hit apply. So this graph has a slope. So M is your slope is 4.306. And you're going to use that for your concentration of your unknowns. So you just get to keep this graph as such. Print it out. You could go over here and save as. You could export it as a PDF. You could take a screenshot, whatever you want to do. They already have absorbance over here and concentration. You just need to add a title. So if you go down to Graph Tools and you go to Edit Graph Options, you could type in absorbance versus concentration of cobalt fluoride is a good title that you can use. Okay, so once you have that complete, there's only one other step that you have to do for this lab. So for the last part of the lab, you are going to be reading 3 unknown samples on 1, 2, and 3. And you're going to be putting the absorbance into this column here on the lab, okay? Because you're not going to graph these, you are just going to put in, so this is sample 1. I'm going to put it into the spectrophotometer. And what I'm going to do is change to the actual screen so we can see the absorbance. So if we go to that screen, you will see that the absorbance is 0.367 for unknown number 1. So you are just going to record that in your data table on your piece of paper. It is not going to go into this data set here. What instead you're going to do is use that slope and take that absorbance to figure out what the concentration would be. Because again, every spectrophotometer, you need to create this line. You need to create the slope so that you could read any other sample from that. But you could kind of take a general guess. This is 0.363, so it's somewhere between the concentration 0.09 and 0.06. So you could also use, I believe, you could use a toggle and you could move this back and forth until you get to the absorbance that you want. So my absorbance is on the y-axis. So let's move this over so that we could get it close to that number. Again, I wish this would toggle a little bit, but it's going to be somewhere over in this area. Again, let's see if we can move it this way. Nope. So you'll be using the slope to calculate what the concentration of those 3 unknowns are going to be. So I hope that this little tutorial will help you to read the samples a little bit better. Again, this is different than the other spectrophotometer, so it just has a couple different steps that need to be done.